Hello everybody, welcome to another stream. How we doing? So last stream we basically got our shaders kind of compiling, and then we encountered a bug. You encountered a bug in the in our custom C compiler. So we're gonna start by fixing that bug, and then all the shaders should compile for the LOD and cluster creation, and then we'll be able to basically start plugging these guys in, which should be super cool. So yeah, let's just quickly go over to HCC and continue on trying to fix this bug. Like we fixed, yeah, we decided to not use bit fields anymore because storing to bit fields has a bug, and it's a bit of a pain to try and support, I guess. So we decided just to manually do the bit packing ourselves, basically. But there's another bug. If I run this, we get an error, whereas they're saying there's two function types with the same signature, the same prototype, right? And I'm logging it out here, and I can't see a duplicate anywhere. So I'm a bit confused. So we're basically trying to fix this bug at the moment. So hopefully we can get this done pretty quick. So basically in the HCC compiler in source spear v, we have a deduplication table where we say, hey, I got this type, deduplicate it for me, and store it in a table somewhere, effectively. What I would like to do is possibly should do it for every single time. Yeah, but this is a confusing bit. If it is new, then it must come in here. I don't know if there's any other time that we make one of these guys. It's just really confusing. Let's grep for this. HCC spear v op type function. Right, so there's only two places it's used. One place where it's declared, and one place where it's used. And this place is here. So the only other time it must be added is when it's the only time it must be added is when is in an invalid way. Because if we're trying to compile and run it here, like I think the prototype is complaining about is that there's one with a uint. Oh, wait a minute. That's the return type. This is where I'm probably getting confused then. Right, I see now. Okay, so where you've got uint, it's right here. Right, this is the type that is getting made twice apparently, or emitted twice in the final in the final spear v binary for some reason. Right, so we need to. So apparently this is 12. No, 12. That's our internal data type thing. we need to know what the SPIR-v1 is. And when we sort of pack it into the binary, we'll inspect that code and see. Basically, we'll print out some more stuff. But yeah, this is confusing because the strangest thing is we have used many functions with the same prototype, and this problem has never happened. So it's just weird to see this happen, basically. So this one here has been apparently emitted twice for some reason. We'll have to see why. So this is where this is the code that prints that debug stuff we was just looking at. So what we want to be able to do as well is put another integer in there, and we'll do an arrow and to that integer, and we want to just say, you know, after it was deduplicated. Oh wait, no, this is it. SPIR-v type deduplicate. Questionable. It is 12. Okay, 12 means unsigned int. Yeah, because it's deterministic, so they'll be the same. So what we need to do is we are simply going to, when we do the packing, right? So that's in SPIR-v link. It's called like types and constants because they can go into the same section basically. So this is it, just emitting it in here. I think if we look here, we have like an op. Yeah, we have an op here. So we just go, hey, if the op is equal to this HCC SPIR-v op type function, right? Yeah. Then we'll do the printing. So what I want to do is I want to, we can say if we've found the 12 one, right? We can basically count, right? We can just say like, you know, if operands count I wonder if that's over. So what goes in 0 again? Yeah, it's just the SPIR-v ID. Okay, good. So we'll do the SPIR-v ID. We'll print out of this. Oh, okay, so equal, you've got 2x, right? So you've got the return value and yes, you've got the SPIR-v ID, the return value, and then then the two parameters. Yeah, that's right. There's 4. Yeah. So the one was do a lovely little print here, basically, and this print is just going to say %, then %u equal. Oh, okay. Right, found sort of the function, let's just call it that. Found the function type, SPIR-v ID, this guy. That's all we'll do, right? And then we'll print out type or constant. Operands 0. Excellent. So that would be pretty helpful. So the one other thing that we need in this debug information, and that is we should really print out the actual SPIR-v ID here. So where do we assign it? Do we allocate anywhere? Not yet. Damn it. Right, let's debug it this way. Function type %u. Plop one of them in, yeah? Okay, so with this, we should be able to compile this now. Take this binary. Yeah, it crashes because I've updated Spivvy Tools, and Spivvy Tools has decided to introduce a bug, but it's alright. Don't care about it. Right, so in HTC, we're going to print menu binaries. Just grab this guy, hop over to Game Van Engine, go to third party, here, drop a new binary. I should probably have a script for that, but alright. So now we can run it in here and see. Okay, that wasn't helpful because there were so many of them. I was expecting 2, so this must be wrong. Oh, wait. Did I do the condition completely wrong? I just realized. I didn't say if they're equal to 12, did I? Right, my mistake. And type or constant operands. So the parameters start at 2, right? So that's got to be equal to 12, which means unsigned integer. And then 3 as well. And then that's what we're looking at, right? So again, we'll compile that. We'll copy that, paste the new build in here, and then give it a spin. Right, so now there's still some, which is weird. So maybe because they have different return types. And so the return type is also an unsigned integer. What are you talking about? There we go. Yeah, so that's where the return type is, right? It's in operand 1. So recompiled that, and we're just gonna hop into here, get back a few of these guys, grab that, forward a few of these guys, and plop that in there. Right, so there's a new binary, and away we go. Okay, we've only got 2 places now. Excellent, this is what we're looking for. So 81, this is the one I was expecting, right? The one causing us a problem. Then 3227. Here it is. Aha. I see the problem. So what it is, and it makes sense now, is this built-in type is just an integer. No matter what this thing is in here, all buffers and textures are just integers, and then we look them up into an array, basically get the descriptor. So yeah, I gotta be really careful. So I think when okay, I know how to fix the bug now. Right, this is great. Okay. So basically we have to sort of resolve it into some form of like lowered version. Effectively, right? So let's go over all the debug stuff now. Don't need it anymore. So the fix is in the core where we do the original deduplication of the function type. Here we go. So we do a resolve and say keep qualifiers. That's not good enough. First of all, you need to sort of lower it. Lower data type lower from an AST to the abstract machine language. So that's going to do a resolve. And then it's going to basically say, well, if it's like, converts it from stuff like int, long, and short, and converts into more specific types depending on the platform. But But one thing it doesn't do is resolve it doesn't resolve the resource types, which is not a big deal because it's very easy just to do that here. So we just have to say, right, if return data type is equal, if HCC data type is equal to data type resource, right, meaning it's a buffer, texture, or a sampler, then this is just equal to HCC data type abstract machine language intrinsic U32, and that'll fix the problem. That's literally it. So this would mean, not just for the return data type, we've got to do it on all of them. Okay. Param. And I kind of did it twice as well, so it's down here when it actually commits it to the table. Alright, so we should just be able to compile that. We'll give it a test, and then we'll just... Right, so again, this is Spear VOpt, it's got a bug in it. It had a regression, unfortunately, but it's not a big deal because it only affects the sample code in the HCC repo and not the actual game we're working on. So, all good right there. So I'm going to copy the binary we just made, put it into the game without engine repo, give it a compile, and voila, there we go. So now this is Clang's errors. So that means the shader's successfully compiled. So now we're going to go into Clang and then fix those errors. So this means we might as well now just produce a release build for the compiler. So it's proper. Just quickly do that. Build. Oh, not that one. Release. This is going to build an optimized build. There we go. And we can just now close that. We should really commit it. I got to remember to commit this after the stream and do a Windows build. So the Windows one is fine. That was a good. Let's quickly do the commit. Right. So. Fix function data types not being deduplicated properly. Properly when as they were not aware of their sort of how the types got lowered into the same underlying type, right? Something like that ought to be good enough. So I'll push that up later. So now all the shaders are compiling, which is great. What we want to do now is get the CPU side compiling again and get it up and running, and then we can commit this code. I can push that up to the GitLab. So we've got it all backed up basically, because we've just done like a whole bunch of like we've basically like planned out all of these shaders. There's like 6 of them of varying complexities, and we've got this like, I think we kind of update, no wait, what did we do? Yeah, we might have touched up this plan a little bit more, but probably not much. Yeah, just be good to get it all backed up before we start plugging these things in, basically. Okay, so we're going to fix these bugs quickly. Right. Are we uploading those to GPU anymore? I think we might be. Oh, damn it. I think we can read bit fields. We can read bit fields on GP. That's fine. We're writing them as we've got a bug in our compiler now. Yeah, maybe we should probably convert these into into some manual code anyway, because what's the issue? Yeah, because they're going to be serialized out to disk anyway. But I guess I was just sketching it out and to begin with. But anywho, let's just ignore some of this. Yeah, we'll yeah, so we just was putting one sort of edit down, or let's ignore that. Alright, we need to pre-initialize that free list at some point. I guess those can just be well, we might initialize them anyway for safety. Doesn't really matter, it's all just getting copied up anyway. Let's just zero them. Okay, so it's all compiling. It's been a while since I've ran this. So what I want to do is like do a diff on probably specifically that file, right? Where all the graphics code is. So we've sort of like added oh, we've basically done nothing. We just made some more buffers. So basically this should just still run the way it used to, right? We're not launching any different shaders. So yeah, fingers crossed. If a stream dies, I'll be right back, you know the drill, but it should be alright. Build game. Right, yeah. I don't know why we're not getting any mouse movement anymore. Why am I not seeing the mouse move? This is a real shame. But yeah, so we've got two model instances working. This is obviously not with the new LOD cluster stuff, because with the new LOD cluster, we'll have much higher resolution. This is the old stuff. But I'm curious, why is the camera... Did we unplug the camera or something? Right. So we added the quaternion. We added all this new shader code, which is super awesome. Hence why I want to get it backed up. Where's the camera code? Very weird. doesn't appear like we've changed any sort of... It's right here, the camera code. So this should ideally be updated, right? Oh, why did I do that as an int? Right, so as we move that Y coordinate, we should see it. Alright, so it's not picking up this mouse for some reason. Oh, right, I've plugged in a different mouse. So it might not be picking it up as an input device. Or something like this. Which is weird. No. It's using the virtual keyboard and all that. Oh, wait, this is the wrong one. This is not mouse. This is the view. This guy, this is one we want to look at. Alright, let's roll with that. Right, so again, that's not being updated either. Very weird. That's using an input device. I thought we were using the virtual. Oh, right. The mouse that I've got has two, it gets recognized as two things, two devices. And one of them is a mouse and a keyboard, one's just a mouse, I think. And I think we're overwriting that global variable or something like that. That's why. That's alright, we'll just do that. No? Right. It's because you got this in here as well. There we go. So we've got the look around working again. Okay. So now it's time to commit this code. So basically here what we've done is we've added, we've sort of like sketch out the, is it just saying it wants a capital? Alright, so sketch out the, initial shaders for LOD and cluster creation. So that was a lot of work. But now we have the fun of plugging it in and actually seeing how it works, right? So that's going to be super cool. So let's go over to the actual shaders now and see what we've got to plug in. Yeah, there's so many things I would like to do. But I guess let's just start plugging it in. One by one. Like I want to basically update the profile information to have more, to like a tree view instead of just a linear list. Because right now we've just got a linear list of things, and you kind of want to say like this is a group of shaders and see how they all ran in total. But yeah, because we've got a whole bunch of shaders which work kind of together. But anywho, so it's time to get this boy working. This is the first one. Now, these kind of need to move into the right place, not gonna lie. These shouldn't be sitting here. These need to be moved into the shared header. Oh no, this needs to be moved up here. All this stuff. So these are the push constants that get passed into the shader. So just move into the right place. Right. So the first one we want to call is this volume constructor reset. So basically this is the thing that we're building, right, is this volume. We're constructing a volume. That's like an LOD cluster tree thing. So this one should just work super easy. We might have to make a few things though, but we'll see how that goes. So basically I want to run this thing every frame, and we're just going to run it at the start. Well, one of the first shaders, I reckon. So after frame initialize, so we'll do it here, right? So after frame initialize and clear, where it clears the surface, right? We're gonna fire off this construction every frame. All right, very good. So the only thing we need is the volume cluster nodes, and that needs to be write only. So this is where all the node. So basically, let's get Milton up. Each volume, when it's being built, the way we're going to do it, going to be proper cool, is we're going to have one lovely buffer for, one lovely long buffer, and this is where we're going to build the volume in. So we'll allocate all of the nodes in this sort of octree, LOD, octree, and there's like a midpoint cursor which starts somewhere. I think it's actually to the right, because you have more potential leaf nodes than non-leaf nodes, and that's another thing about this. Leaf nodes are allocated to the left, non-leaf nodes are allocated to the right. And all in all, this is a 16 megabyte buffer, roundabout. Probably, maybe a little bit less, because we need, it's 16 meg times by size of node. Yeah, whatever that is. So where is it? Where's the node? Volume sphere. Right, here it is. Cluster node, that's a 32-bit set. So 1, 2, 3, 4, 5. Oh wait, no, got a whole bunch of these boys. That's there's 8 of those, isn't there? So there's 12. There's 12 units. So 48 bytes. So 48 bytes times by 16 meg, basically. So it's like, well, there's 250, because that way it directly, we can multiply this and it'll be exactly a meter, times by 4. So we want it to be 250 cubes, so it's about 15 meg, give or take. And times by 48. So it's about 750 megabytes. Maybe a bit much. Maybe we need to pack it more. The problem is we've got an array of these. That's the issue. The rest is kind of alright. But if we're going to say that a volume is only going to have, like, we can manually pack 16-bit integers basically. Be a bit of a bugger, but it's all possible. Yeah, we need this bit set. This bit set is vital, but we only need 16 bits of it. That's another thing. So these two could go together. This can go in the top bits. So yeah, we could put this and this together, and then that will save us 2 more bytes. Then this can be reduced to an array of 16-bit integers, but we've got to manually pack it because GPUs, right? Like potentially the hardware supports it, but I'm just not going to bother. I'm just going to keep with 32-bit integers and just live with the pain, I guess. So all in all, then that would be 1, 2, 3. It'd be 7 instead of 12, right? So it's 28 bytes. So we're over half of that now. But I wonder if we can get it to even less. Wait, because are you going to be having how many of these boys are you going to have? That's over 65,000, isn't it? Yeah, but it's 120. Ooh, 5. Just trying to figure out if we can actually pack them down into 16-bit integers or not, because the number of nodes is 125 cubed, and that's a million, and you only fit 65,000, obviously. And a 16, well, signed in, which would be 32. Oh, it doesn't matter, it'd be 65,000 still, give or take, somewhere in between there. Yes, unfortunately that doesn't hack it, you know. So we can't save. I can't save any memory there. You know, I don't want to be using I don't want to have like you know, tons of memory reserved. So what's the ideal number that I would like to get it down to, basically? So this is 15 megabytes. So yeah, it'd be 315 megabytes, wouldn't it? Just for the clusters, if we times it by 24. So we had, so if times it by 16 bytes, that's still 250 meg. I was hoping to have 250 meg in total for like the building space, basically. And we're doing that alone with the nodes. Um, See, I could reduce the maximum size of a cluster, sorry, of a volume, from 250 cubed down to maybe 125 cubed, and that would be obviously dramatically better. So that would only need 7 bits. See, that's only around like 2 meg as opposed to 16. So this number could probably, like, if you used to have 32, right? That's only like a size of 32 bytes per node, say, which we can. Right, let's undo that for a second. Right, 125. Let's say we times it by 48 and didn't change it. You're looking at 93 there instead of 700 odd, right? Which is a lot more feasible. So the great thing about 125 is it's a number that's directly divisible, or directly fits. You know, you can it can directly go up to 1,000 basically. But I've also got 200. If I had 200, because times 5 that's 1,000, which means you can have 200 mil. And that can go up to 1 meter, which is kind of nice. So this will make it so 200 cubed. So 200 cube volume of spheres is about 8 meg. But then times by, so that's if they're all 1 byte of information. 48, say. That'd be about 300 odd. So that's about half of what it was. See, I wonder how limiting a 200 volume is. 200 cube volume is for actually creating stuff. We could also just tweak these numbers, and just get it up and running basically. Because we might not see until we sort of like actually have it. And to be honest, I have the resources on my GPU, so it shouldn't be a big deal. So for now, let's just allocate what we have and have a play with it and see sort of like, wait a minute, let's just make sure we're not going too crazy and overboard. So in the maximum number of spheres, we're fitting those down to a 16-bit. Well, they're not kind of fit down yet. We need to work that one out. Yeah, so say if right now they're 4 bytes each, but they should be 2 bytes each. So volume. Wait a minute. I've done the cluster node calculation slightly wrong. Slightly wrong. Yes, it is 125 cubed times by 48. Yes, there'll be 93 meg. Yeah, because clusters are 2 by 2 by 2 spheres. So you have basically half of them across each dimension. Right, so maybe it's doable actually at 250. Yeah, it's this, we can bring this 48 number down, and that'll bring this number down a whole lot. So that'll be good, I think. So then let's talk about the spheres, how much this is going to have. So that's 93 meg if we don't change anything for the cluster nodes. So 250 cubed times by, we've got 4 bytes right now, but this should be 2 bytes. So that's 62 meg. So all in all, we're looking about 150 right now, which is good. Then we need to allocate like a bit set as well. So it's this divided by 8, rounded up, so 32 cubed. Yeah, easy. This is drop in the water. 32 KB for a bit set. No, it's a repeating bit set, so it's a little bit more. That's alright. That's alright. So it'd be like 64 times 64 times 32 in one dimension. Yeah, drop in the water. Okay, so I think the numbers are looking alright just to go and allocate. So what we need is an array of these guys. So let's hop up. We're going to hop up to where we initialize in these buffers. So yeah, this is the new stuff. Yeah. Volume, cluster, nodes, and buffer ID. But this one is for the constructor. Yeah, and there will be a final place where they end up going. I'm not kind of. We need to make a certain like heap allocator for, or a free list allocator for that at some point in a defragmentation system. But that's all a bit of fun that we can save for later. No need to worry right now. So yeah, basically we want to do a volume volume cluster nodes buffer ID. Yeah, you know what, let's get rid of this one. Let's just do the one for the construction. Yeah, we don't need the other one. I'll be thinking too much, you know. Volume, cluster nodes, constructor buffer. Yeah. So we basically need for the largest possible volume. So max leaf nodes. So there'll be another one, right? Max cluster nodes. And that is leaf nodes plus non-leaf nodes. Alright, so we can get this, plop it in there, and this is time volume cluster node. Excellent. So now we've got this guy. It's as simple as volume cluster constructor, or maybe not. Right. So we just got to say, okay, I've got a GPU resource. Can I get its index and give that to the GPU? Then all I need to do is dispatch. Well, no, I need to do synchronization code for this resource to say we are writing to it. And then I need to say, hey, I got the shader. It's called volume constructor reset. And we're launching 1, 1, 1. Right, we only want to launch one thread, one group with one thread, basically. And that is it. So the next thing is to get this thing running, or is just to run it and see what happens. So basically my AMD GPU does crash, so if a stream crashes, I will be right back, but it should not crash, right? Because we're just writing, we're setting up stuff in the global, and we're writing into the nodes, and this should all be fine. Technically, that'll be alright. There could be a better way to do it. You can just use all the other threads, basically, but I don't know. You don't need the for loop. We could just do this. Then we could just say if BC dispatch index is not equal to .x, not equal to 0, return, and then let the single thread do the rest. Oh, sorry, what am I doing? And that'll be dispatch index, right? And this will be based on the cluster children count. So you're basically 8 threads right in that. And then you got the single thread right in these. There you go. That'll be better. Not BC. SV for system value. There we go. Yeah, but it's probably very negligible, right? It's kind of a, but anyways, it's a bit better. All right, let's give it a run. Okay, so it seems to be running successfully. As you can tell, it's a dirt quick shader. It's right here. You know, it's 12 times faster than clearing the whole screen. But yeah, when you get this low, there's not much faster than you can get, I'm pretty sure. There's this one here, which is apparently quicker, it's doing nothing. I think just to launch a compute shader, it kind of costs this much, right? So, yeah. And it's not even leveraging all the threads in that. Okay. So, now the next thing we want to do is try a complicated shader, because this is the next one. So we can quickly go and explain what the shader does. Let me read these comments and see if this is any good. If not, we'll just delete them and maybe write some more. We dispatch LOD count number of... Yeah, we're not doing it in tandem anymore, in pairs. We're not doing it together in pairs, right? Let's get the music. Right, for each lob one at a time from high to low. Or sorry, from low to high. So, hey, Cat Payne, I know, right, man. Compilation, isn't it going to be amazing? We're finally, the old game works. Look at that. So this is obviously not any of the new stuff. The new stuff is going to be far more exciting than this. This is like, this is going to look way better. We'll have many more balls in the future. But yeah, so we've got these sort of like, so we're going to build the first LOD basically, and then the next LOD. And we're just going to go down the whole tree and build it all, right? And so the first one obviously is 2x2x2 and it has one cluster with 2x2x2 spheres. Then when you go down to LOD1, it's going to construct this one. I wonder if we... Yeah, so we need to double check over all this code before we even run this thing. Because it's very complicated. All this stuff exciting me, I think it's called AF, nice. And learning about time complexity and LODs, etc. Awesome. That's good. Yeah, there's not much resources on this sort of stuff. You just gotta like get in there and do it and read documentation, or sort of like work with people who have done those things, right? And sort of learn from them. It's yeah, not many people do sort of like GPU stuff nowadays. But it also be good just to be done with the GPU stuff and just get on with doing some game design and stuff, and more sort of find out what this game is going to be. But until that day, until that day. So this shader runs over a whole list of edits and then constructs an initial tree. Yeah, so it kind of like basically as a way of compression. So we want to, this is not the number anymore, it's actually 250, right, cubed. So basically we're filling up, we've got, like you can basically, like storing this in memory. It's probably possible, but if you just have like absolutely tons of game assets, you quickly start to add up to probably like a Call of Duty game quite easily. Maybe not so much anymore, we'll see. If they're instanced quite well. Oh no, we just did the maths when it was like 250 meg. Yeah, but like 250 mega model, it's not good. At most. Yeah. So, what we basically do, oh shoot, I just realized we might not allocate enough memory. True, yeah, but that'd be fun though. But hey, good foundation at least. Usually best. Yeah, definitely. Yep. We got like a nice little engine, and it's all like going to be quite easy just to edit basically and do one of it. So it's going to be sweet. Hopefully, have some quite unique features as well. So, yeah, I just realized I think the memory's wrong. We messed up with the memory. We need more memory. We need... Oh no, we don't. I already did the maths. I already did the maths right here. Don't worry. I was thinking that we needed all these different level of details. But this is what the non-leaf nodes are. Right? Excellent. Right, now back to this train of thought. So the idea is these, like, I used to have these volumes on disk and like read them in, and they'll be kind of like quite big and take up maybe take up a lot of space on the GPU, oh sorry, on the disk when you ship it. So there's a little trick you can do where basically but it also has another added benefit where you can essentially preserve how the thing was created from the beginning. So basically we're borrowing an idea from Dreams that has a sort of SDF creation tool basically on the PS4. But that sort of technology is uses sign distance fields and to compute sign distance fields, whereas this one is mainly we're just trying to have a 3D volume of spheres and then sort of do what we want with that. But the trick here, the trick they use is rather than storing a 3D texture on disk, right? So they store a bunch of edits, and these edits are very small. They're about maybe, I don't know, 2 bytes of memory per edit. So if you have thousands of these, it's working at KBs, you know, like working at KB rather than MB, right? The megabytes. So we could basically say, you know, I've sort of drawn these 3 shapes here, and then we've got a compute shader which runs over and generates tons of little spheres that this sort of edit, if you will, goes over. And the way it does this is it starts from the lowest level of detail, which is only a 2 by 2 by 2, which covers the whole area, and it sees if those edits influence these, and if it does, it will put it, you know, like, so these sort of edits target an LOD, so they specifically target LOD 5 or LOD 2, so they only will paint over those areas if they have that target, right? So we start off the highest level of detail, and then we dispatch one set of shaders. We dispatch this for LOD 0, then LOD 1, then LOD 2, and so on, and we build a tree going down from the lowest level of detail all the way down to the highest. And this isn't going to have a complete tree, because again, we're only going to build for the level of detail that this is targeting. Say if this targets LOD 4, this edit's only going to apply to the nodes at L4, right? So we still haven't built the actual lower level of details of that edit, and that's where the future shaders come in to fix that problem. So I guess we might want to list that in here somewhere. This does not finish the following aspects of this tree. Yeah, lower LOD is not supported. Some nodes will have allocated children, but will have none. Is that true? No, we'll have a contiguous array of leaf nodes. We fixed that problem. Hey, Silvercore, it's been a while. Yeah, hierarchical, that word, LOD, using clusters, exactly. And the beauty is each cluster is a 2 by 2 by 2. Meaning that it should be easy to sort of like we can use a lower level of detail. We can use a lower level of detail quite easily, and reduce the number of spheres quickly. But yeah, we still have to test it, how it ends up working. But it should hopefully be good. So the idea is we're not ray tracing against this. This isn't an acceleration structure. It's purely a way of it's more of a how do we select the spheres to render quickly sort of structure. So we'll start from the leaf nodes across all the threads and just check to see if they're the right, they can render, that sort of thing. Origin has those, but clusters are baked offline. Yep. Yeah, we're going to be doing it as and when they're needed, basically. But I think as and when the volume appears on the screen, or maybe in the scene, I'm not sure yet on that one. We'll see how it goes. So I'm curious about this comment I left. So this comment here says some nodes will have allocated children, but will have none. Right, I've just got to double check this. Yeah, so I think basically when we allocate the children, we say if the edit that you're brushing down is bigger than the construct LOD that we're currently constructing. So we might be currently doing LOD2, but you're brushing down LOD4 on that in that area, which means we're not really going to put anything down. We're not going to be putting a sphere down here, but in the future when we do the higher level of detail, we're going to need it. So we didn't put down a child node. Whereas this one, we'll say your target LOD is less than the construct, which means you don't have any children because this low level of detail would have been brushed down and destroyed the higher level of detail, right? Sorry, destroyed the low level of detail, right? So I'm curious. Oh, yeah, but then you could have add. Yeah, so we could have like painted the remove down and sort of removed the spheres. Yeah, okay, that's true. I think that comment is deserved. So some nodes will have been allocated. Some nodes will have allocate children. But will have none. Something like that. No. Some nodes will have allocated children, but they might be might not have any sort of spheres or children of their own. Before the shader, heap allocate a range of... No. It's nothing to do with that. Right, so we'll say... so we kind of got to say what the shader kind of does. This shader builds a... the initial cluster tree. Builds the initial sort of shape of the cluster tree with all of the leaf spheres placed down. And also the tree is not simple. And also I want to say like the tree is not simplified either. Sort of like high level of detail. Oh, we'll just say something like clusters that are surrounded by other clusters. So no simplification is applied. So clusters that are surrounded by other clusters. Okay, we'll just say it like that. No simplification is applied. Okay, so let's just walk over this shader and just see sort of like if there's anything that pops out. Wait. Let's plug it in first, and then we'll see if anything actually pops out. So with this one, to verify if it actually works, we probably are going to look in render doc and like look at the memory. and just see, like we might zero the buffer and then just like see if it's like set anything, you know. Just double check this for a minute. Right, so which one of these do we need? So the array of edits where the edits start and volume dims at LOD. Probably useful. Construct LOD, yes. Read write to the cluster nodes. Yep. Read write to the free indices. We need to fill this free indices up. So we might need to quickly make a shader. Because we've basically got a fast allocator this way. Alright, so I think before we actually try and launch this shader, this is already good, I like this, but I want to actually quickly write the other real quick shader. Volume, we kind of really want to run this at sort of on the first frame. I don't know why we don't have a frame index. Alright, we'll do just something silly. Static int init equals 0. If not init. Right, okay. So we'll put this in here, and what we want to be able to do is basically those sort of volume sphere free indices. We'll call it like init. We just need the array of free indices. What the hell's going on there? Graphics, internal. Right, sphere. So we need an array of spheres. So let's just make all the buffers that we need for this. So an array of spheres. We also need an array of free list. Okay. So the free list is just a bunch of integers to basically say like, this is the index where all of the, where 8 spheres are contiguous in memory that you can take. And this means that we can basically, we can pop a free index off the end of the list atomically, and we can push one back on the end atomically when we want to deallocate it back. So it's a super nice way of doing, of essentially having quick free list, right? Because they're all the same size, which just means it's a very easy problem to solve. Okay. So the idea I need to get more sturdy arms so that noise doesn't happen. Right. So volume, spheres, volume spheres free list. We need to put a to do in here to sort of make it to do make volume spheres a U16 is a kind of a U32 because GPUs. Do I work in office or remote? I work remote, so I just literally sit where I am right now, and I work. So it's really cool, because I don't have to travel, kind of less distraction. I can make as much noise as I want. I'm also home for my wife and baby, so you know it's really cool just being able to see him more. So yeah, super great. Yes, as a sort of a exactly fella. Nice, you work from home too. Yeah, I think as an employee, it's just such a great benefit. But I think as a business owner, you really have to sort of trust your staff basically, or you need to be able to work from home. And I think a lot of people, a lot of companies just don't trust their staff basically. You know, you should be able to really pick up on people not working right. But maybe like a max number of spheres, max volume spheres. Okay, so what is this? Yeah, the maximum number of spheres that you can have is probably just this number here. Wait, this is even the wrong number. Yeah, I understand if it brings higher standard. I understand if the higher standards are higher for remote positions. Yeah, it makes sense, doesn't it? You have to have someone who's like, yeah, that's a good way of tackling it, I guess. It's just a proven person who can work from home or whatever. Yeah. Some people really like The Office, and I do find that The Office is really great to sort of like just communicate and speak with people and work together a bit, and build a sort of initial relationship. Because you know, work from home. Even though I did do it right, I joined during COVID, and even to the point where my boss went on holiday on the third week of me being there and gave me a task, and he left me to do it, and I completed it by the time he came back, and he was happy, and it was really cool. But as much as it is kind of great to onboard people in the office, and it probably is better, it's also not really needed, because I ended up quite fine. But maybe that's not fine for everyone, right? I'm a single sample size person. But yeah, we'll see. I think quite a lot of like big tech companies are trying to take people back to the office, but I think it's kind of like 50-50, which is great. I like that it's become a thing. The max leaf nodes, this number is actually wrong. First of all, put 250 cubed. Second of all, there's 125 clusters because they're half the size, or they're twice the size of a sphere. Oh, meaning this number is also wrong. Yeah, this number can be wrong. I'm gonna allow this one to be wrong. We want to go up to, but we want to remove this number from it. Right, so it's 1953125 take away. Oh yeah. Kind of actually a little bit wrong on number. Let's do the 128 to remove that one from it. Because I did square numbers. Oh, I did powers of 2. 209, 71. Excellent. Right, these numbers are correct now. I think it would be fine to have in-office work periodically, like mocap sessions as an animator, for example. Right. Yeah, I think we try and do like every 2 months, basically every month or 2 months. Yeah, I haven't been in the office for a while actually, like 4 months, but we try and do them every about 2 months, and do these sort of like basically just conversational things because I'm planning in person. But yeah. It's very difficult to go into the office and just get work done because you need to have like you need to have a PC set up, and I just haven't quite set up a PC at work for me. But yeah. I think some people work both half remote, half in work as well, in office. Oh, this is a free list, isn't it? Right. Gotcha. Yeah, so this free list, this one you need to have 8 less. Wait a minute. Oh, have we done some numbers wrong? Done some numbers wrong. I think, so the maximum number of spheres, you've got per cluster 8 spheres. No, we can't have 250. No, what is it? Oh no, it's 125. Yes, it's 125 cubed times 8. That's the number of spheres you need. Sorry, 125 cubed. Right, because that's how many clusters we're going to have. Cubed times by 8. Is that the same number? Oh, it's the same. It's the same number. All right. Okay. Okay. All good. The maths checks out. Right. There we go. Oh yeah. So this lovely little shader that we're working on basically just sets up this free list buffer where each index just has, it's just basically sums of 8. Wait, is that right? Yeah, sums of 8. It's just 8 times an index. Maybe I mean, maybe multiples of 8? Yeah, that's the way of saying it. Maximum volume spheres count. So you've got, this should be divisible by 8. This is the problem I was thinking about. Oh yeah, it is divisible by 8. We know it is. Yes. Excellent. So now it's going to be legendary. Put the spheres free list, plop that in there, and then we're going to run a new shader which we've got to write quickly. Spheres free indices. How have I called it a free list and free indices? And damn it. Alright, it's a bit better. Free indices in it. And we're launching, so each thread, so be a divided roundup where we need to launch this many divided by 32. We have 32 in a wave going at a time. And away we go. So let's get this shader written up. It's be nice and easy. The flexibility of doing both is what matters, I guess. Yeah. True. Yeah, the benefit that the company gets as well is they don't need they need less office, less renting space basically, and all the energy and insurance and whatever. It's just less of all of that, isn't it? It's pretty nice. Like if you're like a small studio, you can maybe get away with no office, and you just sort of hire a room out when need be. Right. So I haven't made this thing yet. Make one of these boys. So it's a write-only buffer, and it's just going to have a bunch of free indices in there. Volume, spheres, free indices. Oh yeah. So now we're going to actually make this shader. It's probably going to be like one line of code. They're the best shaders. 32. Let's just copy the name over. Nice. Yeah, so basically we do a super lovely volume spheres list. Wait, free indices, right? And we've got ourselves a dispatch index, right? So this will go 0, 1, 2, 3, 4, 5, 6, right? 32 of them are in a wave, so they all happen at the same time, right? And we're having many compute units launch. Each compute unit is 32 threads, and you have many compute units. And these are all going to set a value, and that value is going to be dispatch index dot. So I might do it in reverse, because then it means that we'll allocate the low numbers earlier. And that might be better for debugging, I think. But the high numbers means you fix any problems with the bit. No, it should be fine. Yeah, anywho. Yeah, we ain't got any problems with that. So we should probably have like a maximum number of... Yeah, we need a bigger... But that's in a global, isn't it? Yeah, it's in a global somewhere. Sphere's capacity. Yeah, so we might want to do the maximum number of spheres to be this number per se. Yes, that's maximum number of spheres in a volume. And we'd probably say like max volumes kind of thing. And whichever one we'll probably have a max number of max volumes, or max sort of like max full volumes, or max full volumes. So maybe that's like 1024. Maybe that's way too many. We'll see. Let's run some numbers. Yeah, maybe we need less. Ooh. So these are unique volumes, obviously, because you instance them, right? So it's this many spheres. And that's in about 4 bytes each right now. And say if you had 1024 of those, that's 6 terabytes. No, 6 gigabytes, sorry, wrong one. So probably not a good number. But we probably, if it times by 256, still one gig of memory. But what do GPUs have nowadays? Yeah, maybe. Like again, this is like the things you're seeing in the world, right? So maybe 1 gig is kind of alright. So but anyway, we're just gonna do 128 right now. And these are full volumes, right? So say if you have lots of tiny volumes, they're not going to use the maximum number of spheres, so technically we'll be able to get away with probably way more anyway, right? So that's probably alright. Have you heard of VCC, the capacitor HCC? No, I have not. Have you a link? What is VCC? Oh no. The Vulkan Clang compiler. Result of 3 years of research at the computer graphics chair university. It's what the name implies. Clang-based compiler outputs runs on Vulkan. Whoa. But to retire the... yeah, this is what we want, right? But it's funny how they used Clang. But anyway, it's fine. That'd be pretty cool. I guess they can bring the, they can bring the whole languages. The DXC compiler is basically Clang. They forked Clang and made it compile HLSL, right? Unforeseen features, physical pointers, right? Generic pointers. Eliminate address space from pointers. Yeah, this is a problem we was facing. And you can fix that by inlining. So they'll probably just use the inliner and fix it that way. Real function calls support and recursion. Oh, I'm not sure if you're going to call that real. I'm not sure why you want to do that. But yeah, I'm not sure if they're actually doing it. Like, this must not be available in Vulkan. Maybe they have it. Like they're either doing real hacks with the code they emit, because I don't like SpearV doesn't support real function calls. It doesn't support recursion, but you can probably do some hacks, basically. Yeah, that's another problem as well. Why they call it a Vulkan C compiler. Hopefully it should go to something else. So if they're talking about like replacing OpenCL, that's fine. But if it can be used for like other stuff, like other shaders and that, that's cool. Right, so let's just skip all the English. Just get some code. Right, so they're doing fragment shaders, that's cool. Right, my first problem. They're talking about this, right? Okay. Retire the concept of shading language entirely, right, or whatever. They're not being opinionated here and here. Like, they're just doing, like, this should be automated, right? Location 1 and that. All right, I got 2 problems. Already I can see it. 1 shader per file. They've probably got 1 shader per file. But maybe they don't, because they've got this. But the other problem, but I think they do because they've got global variables that they use for inputs and outputs. And the way we solve that is we have structures, a bit like what HLSL does. And also they're not using, they're using descriptor sets, which is dumb. They should just be all in on binderless resources or all in on pointers and get rid of these entirely. So yeah, that sucks. Right, it's probably like better than my compiler in a sense that they're using Clang and they can use all the optimizations and get full language support and support physical pointers and stuff like this. But they're not really showing off, like they've basically gone and copied GLSL and HLSL. And they're not really doing a good job about it. And also, they spent 3 years of research. Yeah, whereas we only did it in a year, so that's a bit long. No, I don't really care about it, to be honest, because it's probably just like this is just so old. Like they're not trying to push the envelope. Like we do full binderless. Like this, like even we've kind of reserved back and not gone all in, right? We could have gone all in on pointers, but the problem is I wanted to get this to work on like other graphics APIs, but we've got like, right, we've got this resource ID on CPU. This is just a 32-bit integer, right? It's just an index, right? Then on GPU, if I can find one of them, this is just a 32-bit integer. This is just a 32-bit integer. It's just a buffer, and you can set these guys, pass them up via push constants. Buffers and resources are data at the end of the day. and you can access them in a variable manner. Like, no one cares about descriptor sets anymore. No one cares about like uniform buffers, you know, any of that. Just like move on with the times basically and use bindless resources. Like WebGPU still doesn't have bindless resources and it's silly. But yeah. Anyway, that's my thoughts. But it's kind of cool, right? I respect that they're, you know, saying be gone with shading languages. I do agree with that. But yeah, they kind of should have advanced at the same time a bit more. But yeah, how's it going, Chris? Right, I want to put in like a volume. Right, this is what I was thinking about, right? So, oh, I might want that thing back. So, two things. Maximum volume spheres multiplied by maximum force volumes. And this has the maximum number of spheres. So the free indices. So we should probably have stored in here somewhere. Hey, this is the spheres volume spheres capacity, and then also, wait, is that what we need? Yeah, that's what we need. So GFX volume spheres capacity. Good. Went to work this week. Awesome. And I'm already starting to feel tired. I know what you mean. So I'd have a cup of tea to sort of feel awake right now. Yep. But last week, I went to work last week and I managed to get a nice task done, which is good. Oh. Alright, it's getting a bit warm. So this week I'm on a new task. So I'm just sort of preparing for that one. But in February I'm away for a whole month again, so basically all about going full ham and getting stuff done before I go away again. So yeah. Ugh. Yes, the spheres legendary. So this thing, it would be nice just to have that sort of just in the global buffer, right? Put everything in the global buffer. So these things, I don't know if these things were initialized. Maybe they weren't, maybe they weren't. Right, so ooh. This needs to be persistent, man. Damn it. The problem is this is allocated on the GPU. I might need another buffer. The problem is with these globals. There's a real... Like, not all of them... Like, some of them are like, hey, the CPU's got some stuff that it wants to share, and here's just a whole bunch of globally accessible stuff. But sometimes you just want a persistent... Yeah, so maybe we don't upload the whole thing. So I think what we might want to do is have a byte Yeah, we'll just waste something. We'll waste something. So we'll just say like this is basically the this is persistent memory start. So this guy. So we'll basically have like, hey, here's the number of bytes. Graphics, globals, CPU upload size. So these are all the ones that the CPU sort of like, these are all the guys. All the CPU. So we'll just use offset of this lovely boy. Persistent memory start. So now with this upload size, I think I've got to modify so when you instantiate the GPU subsystem, we need to store just somewhere. We need to store size of the upload size. So GPU, this guy equals spec this guy, right? So when we do that sort of GPU update, upload globals, this one, we pass in this size instead. There we go, much better. So the rest will just not be set. That's the way of solving the problem. So we won't even initialize these guys at all. It's going to be legit. So they'll kind of be uninitialized. Well, they will be uninitialized, and that's fine. Because when we initialize in the shader, this one, we need to say, hey, if sv dispatch index.x equals 0 for the first thread of the first group, we are going to say yes, we're just going to set this to nice value. So be the sphere's capacity. Divided by 8. Right, so that'll put you right at the end of the buffer. Yeah, that'll put you right at the end of the free list buffer. So now the free indices, I think what we want to do, right, is I think take 1, take okay, so what this is going to do, so we just sort of break it down. So this is the way we're going to quickly allocate an array of 8 spheres. So 8 shouldn't really just be 8, right? We've got a thing called like cluster. This one, cluster children. Count. So basically, so we do like, you know, so this gets you, every thread will get a different value here. You get 0, 1, 2, 3, 4, 5, increasing, right? Every 32 of them execute at the same time across a different compute unit. The compute units are not, they start in order, but they don't finish in order. So that doesn't all matter. So the idea is you'll get that sort of value, times it by 8, right? So there's enough of these threads. Wait a minute, could I go overboard here? Right, okay. Anyway, let's just finish this train of thought. So there's enough threads to fill up this buffer. And we're going to fill it up with multiples of 8. But the problem is if we fill up the start of the array with multiples of 8, you know, we pop them off from the end of the buffer, so we'd be getting a very large index. And I think it would just be better if we use a low index. Right, so we want to sort of make sure that the low indices are at the end of the buffer. So the low sphere indices, the low sphere indices are allocated first. Right, it's mainly just so we can debug it better. But maybe in release this doesn't matter, but it doesn't really give you much. But we've still got a bit of a problem, I think, and that is when we launch this guy, what's the problem? Volume spheres capacity. That's fine. That's what we want. Will you be a multiple of 32? Yeah, I think we've got to like say if I don't know if it's a multiple of 32. So if dispatch index is greater than or equal to that, then we want to return. But yeah. Anyway, so we only run the shader sort of first time when we initialize the game. So, right, I guess let's test this boy out. So hopefully this doesn't blow up the computer. If it does, I'll be right back. Right, let's go. All right, I've got a problem. Six, 5. Huh? Oh, did I not fill in the GPU spec with the thing? Right, we're going to where we initialize that in main, right? GPU spec, excellent. So this is obviously set to 0. Size of upload size, so that would be global's upload size. Fantastic. Right, let's give that a roll. Right. Validation error. Lovely, just gotta wait for it to reduce the stack trace because it's parsing 500 megabyte file times 9. I'm dumb like that. Anyway. Alright, so the problem is Alright, thank you for that. I'm not sure when that happened, I did not see that. Alright, there we go, much better. Yeah, sometimes if it disconnects, it will sort of mess up the audio. Thank you so much there, Pete. Appreciate it, sir. Right, so when we do this dispatch... Right, what's the final number? Yeah, we're way overboard there. If we did 1024, you'd half that number and half it again, it still won't be enough. I don't think, right? Yeah, that'll still be in the in that many digits. So we've probably got to do an XY dispatch to fill that many. Or you launch... Yeah, we can do an XY. See, I don't know why there's this limitation, it's really annoying. It makes sense because you're only going to be doing 2D images of this size, probably, right? So what we're going to do is we're going to get the maximum number of... So we'll just do... what is it? Sphere arrays. Count. Plop that on there. And we'll mod... yeah, so you're doing that sort of like min. Pick the minimum between this and 65535. Is it 36 or 35? Interesting. And then you want to do for the y is this divided by that. So rows and then columns, right? Okay, so that will give us something. Wait a minute. I didn't do the divide round up, did I? Right, now I'll do divide round up. Wait, what number are we looking at? Divide round up this guy. Let's do 256 at a time. Or we could just do 32, to be fair, it doesn't matter. Just gotta change the number in the shader again. Maybe it does matter, maybe it does matter, maybe it doesn't, we can care about that later. So this is like groups count, we'll call it. So we'll launch it across the X and Y. So that number cubed, right? 655. Sorry, squared, that's what I meant. Right. 4 gigabytes, give or take. Plenty. So this means then we've just got to flatten it out, right? Do we have a flattened one? We have a local flat, but not a manually flat. Right, we can flatten it. So figure out you flatten it. We just need the... Oh, it stopped when I put the war on the desk. Right, maybe I was a bit too aggressive with that one. Fair play. Thank you. What's the least painful debugger you know of on Linux? Yeah, so you can use one that's sort of built. I think VS Code has a built-in debugger, and people really like that. Maybe I could try that sometime. But if you don't like using that, there's GF made by Next. Like this is the one that we use. Basically it's a GDB front end. So it's pretty cool. You can like customize the theme and that. You kind of have to be familiar with some of the commands, but there's ways to like click and set breakpoints and get it to run to a certain line. You can see the stack. You can see the breakpoints in a list and more things. He's also got a support page with more features and tons of documentation, as you can see. There's even got a way to do like things as profiling information and other bits and bobs. But yeah, check it out. It's pretty cool. So we need a way to sort of flatten the thing out, but we don't have the number of groups in the shader. Is that right? We only have a group index. So we need to have a group X. Oh my days. So in here, we can just say group width, and this will allow us to flatten it out. So we can basically get our actual sort of index, I guess. So you just go dispatch index.y multiplied by that group width. Is that even right? I think that's a bit wrong. I gotta run that. Gotta think that through a little bit more. You don't want to group. Yeah. Times 32. Right. So now all of these guys are index, 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 index. It's something like that. Right, it's more complicated than I expected it to be, but that should work. Okay, so the stream dies, I'll be right back. You know the drill. Right, here we go. Oh yeah, we're running. Okay, so the old game still runs, and it would have ran the thing, the initial shader, but it only ran it once, right? So we built render doc, which I've got to use as custom version because I've not bothered installing the one with the patch. It's not the one with the patch, but the one with just the latest version. So I've got a manually patched version. Right, so we get the game. We're going to queue capture on thread on the first one. It doesn't really matter on the first one, but we can see it here. Oh, why did it do the capture one, idiot? It's not a good idea. How did the stream react on that one? Did it stay up? That's the question. Right, nothing changed. That's good. It was probably copying gigabytes of memory, or not really gigabytes, but hundreds of megabytes of memory, or whatever. I don't know what it was doing. It was taking a while. I didn't trust it. Awesome, thank you, thank you. Right, so let's do that one again. Like, because that buffer was big, I think. I don't know though, why did it take so long? I don't know, it caught the first frame, that's what's confusing to me. Let's run it again. I didn't expect it to take that long. But anyway, the first one got caught, there you go, boom. So, we close this. There you go. You went 16 max. Here's our boy. 59 of those. So this is going to write out to a lovely buffer here. This boy. Here it is, the free indices. Here's our boy. View contents. So initially it's garbage, then after it is still garbage. Crap. No, this is what we want. It doesn't remember it before it for some reason, but afterwards it does. I think this is the maximum number. So if we go to the end of the buffer. Oh, next page. Oh boy. Right, can I view I don't know how many rows I'm gonna have. But right, can I jump this number up by like, I don't know. Right, just keeps going. Oh shoot. Right, so there's no 3, it's 2 something. So this number should work its down to 0. Oh, it's 2 not. Oh no. Oh, is that the length? Not sure if that's for... Yeah, weird. Yeah, I think I have to find a way to improve that. But we should, at the end of the buffer... Oh, okay. Yeah. So into the buffer it should be 0. I think the number is a bit off. Yeah, maybe I shouldn't be doing... Maybe it's not better to debug. You know what? Doing that maths is not a good idea. We're going to improve it. What am I doing with that? Keep that open. Let's just do this. So the start of the buffer is going to get the low number. It's going to be easy, and we should just see increments of 8. And away we go. Let's do a capture. Boom. Oh, it was at the bottom, was it? Oh, excellent, thank you. And we view pages of that, or a page of that, whatever the size of a page was. Right, so let's get our buffer back up. Okay, so start on 0, increments by 8. Fantastic, that's all we need to know. Yeah, no, it does go up to this. No, it does go up to this number. I don't know, maybe there's only so much visible. But anyway, it increments by 8. That's all we need to know. We could... Yeah. All good. So we can pop off the end of the index and get a pop off the end array and just allocate some memory basically. Super sweet, super awesome. So we could reverse it back the other way. Why would that be useful? So it means we can view the spheres in the massive sphere buffer really easily in RenderDoc. That's what it would mean. So maybe we should do it. We're just going to make sure we get it right. Hey there, Alexi. How you doing? Off topic question, what webcam are you currently using? I'm using the Logitech C420, I think it's basically one of the popular ones during COVID time. It's nothing special. Did I say C420? Of course I did. Of course I said that one. I think it's this one. Yes, this is it. 270, C270. It's nothing special. It's like dirt cheap and yeah. Alright. 720p. That's all you need. You know, I could do a better webcam, you know, but it does the job. Yeah. If you don't worry so much about the like this has some auto correct brightness thing, and also my thing tends to be quite small. Like, or if you don't really care about the quality super much, it does the job. Whereas some people might want a crisp image, more higher frames a second, better sort of contrast, I guess, you know, or a much better f-stop or something, you know, just dealing with the dealing with different light situations. But yeah, it does the job. It's pretty cheap too. I use the phone as a webcam, although the camera gets pretty hot after a few hours, so probably not a good choice for longevity. Yeah, I've heard about that. Like, you can, isn't it get like Droid Cam or something like that on the phone and just hook that up to the computer? It's a pretty cool idea. Also, some people use like a digital camera and that they've got laying about and plug that in. But I think some of those have problems where they shut off after 10 minutes. Some of them, it's weird. Okay, so now I've got this lovely shader working. The next step. Wait a minute, I can see the number already being wrong. That's right. Okay. Because, yeah, take one allocation back, which is that. That's the size of an allocation. Okay, so, right, so we've got this lovely sort of cluster tree generate leaf spheres, basically. So as we were describing earlier, this effectively builds an LOD tree and only builds the initial shape of the cluster tree. All the leaf nodes and leaf spheres will be placed down. We dispatch one LOD at a time from low to high to build the tree, runs the same shader, but it doesn't produce lower level of detail spheres, and it doesn't simplify, and there might be some allocations which are not needed by the end of this shader. So we still need to do more. There's still more shaders to come, basically. So let's just get this thing set up, and then we'll right. So the whole edits thing. Let's just get this thing in here. Right, so we've got one of these buffers dotted about. Volume edits, is that what it's called? Yeah. So you need one of them. We also need this guy, the cluster nodes. We also need the free indices. We also need... Wait a minute, when we freed that, how was it? Sorry, when we set up... Yeah, we bump it back. Yes, it should be fine. Okay, sorry, so back to here. So then we want to have the array of spheres as well, because we're going to be writing to that buffer. We want to know, right, so these have got to come from an actual place. For now, we're just going to hard code a single volume to do multiple volumes, right? And how many of these have we got? I think we're only doing one at the moment. We're just doing a single ellipse. So let's just write that. To do multiple edits, right? Dimensions out of this LOD. So this should be filled in something like... Yeah, this should be filled in per iteration, and this would be filled in per iteration as well. So there we go, super awesome. I just gotta quickly do some synchronization code. Command synchronize read writes. They're all mostly read writes, except for the first one, which we just put down, but no biggie, because I'll come back to that one. Cool. So read only, read write, read write, read write. Awesome. So now we've got to do a for loop over all of the so-called LOD. 0 to data LOD count. Oh no, there's LOD and LODs count. What is that about? I don't know where that one is. LODs count is probably in some documentation. I don't know. Anyway, doesn't really matter so much. So we need to configure a couple of things. So the first thing we need to do is set BC construct LOD to LOD, and then volume dims at LOD. After every one of these, we're just going to divide it by 2. Is that fair? I've got to think about that. And then we're going to launch this beautiful shader. I wonder how slow this thing's going to be. And we've got to launch correctly here over every cluster. Dims at LOD. Yes, I think you want to stop. Oh, I've got to think about that one. Oh no, because it's going from low to high, isn't it? Right, yeah, I've got to think about that. I mean, hell, it's 1080p and the highest with the highest frame rate. It's in your pocket 24/7. Why not use it? Exactly. Yeah, especially if you replace it fairly regularly, right? And it's some relatively cheap minor less cameras. Also mirrorless cameras. Sony A5100 used as webcam for streaming and such. Nice. It's still way above Logitech one. Yeah. Yeah. So basically the dimensions of this volume at a certain level of detail, you're going from low to high, right? So basically, is it always powers of two until you reach the level of detail for your LOD? Sorry, for your volume, right? Uh, like first of all, right. So all this edit thing we need to fill in properly still because it's going to read that edit. That's not going to be right. But you basically in the volume that's stored on disk, which we haven't, which we just it's just been sketched out, right? It's nothing. But anyways, the volume that goes on disk, and we should probably say like, hey, this is the maximum sort of LOD you've actually painted down. What's the maximum LOD, right? So maybe we should fill one of these boys in. So grid dimensions. So that'd be your highest. Yeah, so what's the max LOD that you paint down at? Maybe we don't really care about that one so much. Maybe we do. Okay, maybe what's the max LOD you paint down at? This grid dims is like, in the highest level of detail. What is, yeah. So, what's the grid that it takes up? Right, so maybe we should have one of these just dotted about. Like, here's a data volume with some of the stuff filled in. Just fill it all in or whatever. Right, 2 seconds, I just need to check on something. Be right back. Yeah, I think I nudged the mic again. We're getting a weird repeat now. I got too excited and smashed the desk. There we go. Okay. Thank you, thank you. Appreciate it. So we only really need like these boys here. So, right, what's the maximum LOD? Should we have this information? Or should we just keep going down the tree anyway? It might not really matter. You would save a bit of time for stuff that doesn't go, but then again, it's more information that has to be correct. And it's not just implied by the edits. It means you can stop dispatching. That should be right. Let's just keep it. So let's just say like 0 for now. Well, let's just say 0. We're only going to do the first level of detail, to begin with, right? What's the dimensions on? See, these are the dimensions at the highest level of detail. It's really weird because it's really weird and confusing. Because I wonder how, like when you have a very, like if you don't fill the whole 256 cubed volume of spheres at the highest level of detail, if you don't fill that volume, like you target a lower level of detail which has a smaller grid. Like you're not gonna get a full visible so the thing is you're not going to get a full, like there's not going to be, like the only time L0 is going to be visible, right, is when you're fully filled a quad, like an OC. Okay, I guess I don't know what the way of saying it is, but would you say it's like a quadrant, right? That's a quarter, but you're like 1/8 of the space fully with spheres. Would you actually get anything to show up at LOD 0? So for the majority of things, LOD 0 wouldn't actually have anything that's actually visible. And the same for LOD 1 and maybe 2. Right. So there might need to be a sort of a slice of these LODs which actually produce something that's visible. So if something like that were to happen, that's not a problem, is it? But it just means like maybe we can early out when we start from the bottom end of the tree and we traverse up. maybe we can early out at a certain level of detail. I was thinking maybe you can sort of shuffle them up. Like if you only use a small area or something like that. But it doesn't make any sense because the sizing will be all wrong. The sizing would be wrong. So that's something. Yeah, so maybe you have a minimum level of detail and a maximum of detail. But yeah, the grid dimensions will just be in the highest LOD. Right, I think this might be a good place to sort of put a pin in it and have a think. And then continue on later or continue on in the next stream. Because, yeah, this would be a good thing to think about first thing. And then just get started on actually plugging this guy in. Wherever that shader's gone now. Right, so what I'll do is I'll get this code compiling, committed, and pushed up to the GitLab. It's basically there, isn't it? Right, that's all good. As this is going to launch, we don't want that to launch yet. So we shall resume next time. So that still runs, there you go. Woohoo. So we've got two shaders. Get sort of two of the sort of cluster LOD and cluster creation shaders up and running. Pretty good. So hopefully in the next stream, right, which will be on Thursday at 7:30 p.m. GMT. We'll be getting this cluster tree construct up and running. What is the one that's after this one? This one makes the initial tree, and we'll probably do the lowest level of detail first, and then go up the level of details and just check the data in the in the GPU buffer and just make sure it looks good enough. Yeah, I think that we might only get that far, to be fair, because we might have to change some of this stuff about some of the. Right, we're gonna have to check over the shader and probably change over some bit field information. And then after that, we can generate this occupation map. And this thing will help us probably debug the previous thing and verify it's correct. Yeah, I think we're okay. So next stream we'll get this one shader working, and stream after with the occupation map. Awesome. Right. Let's find someone to raid then. Okay, just watching a movie or something. Chris, thank you so much. Yes, we have a Discord if you guys want to come and chill out and chat off stream and talk about programming and the like. I do have a Twitter where I do post visual stuff, but I haven't posted for a while. Wow, what has Twitch become? Okay. Right, I've got a jam. Wait, not doing any C++ today? Oh, come on, Rust. Let's see if there's anyone else. Um. Can't believe I'm this far down. Oh, that's right, Tad. Tad's a colleague of mine. Is doing some dream stuff by the looks of it, maybe? Oh, no, this isn't like dreams. Maybe it is. Let's give Tad a raid. Right. Have a good rest of your... Have a good Wednesday, I guess. I'll see you all Thursday, if not Sunday. Right. In a bit, everyone. Catch you later.